they've been really fantastic over the last few months. They're almost getting past their use-by date. We'll see, but I kind of imagine they're going to taper off over the next little while. Anyway, it's great to be invited to give this presentation and have a discussion with you all tonight. And I remember very well coming over to the Nelson region about a year ago to talk to a number of groups last winter. So what I planned to do this evening was really not to go through all of the science again. I'm assuming people are kind of au fait with where things are at and what's going on. But as Julie was saying, I've been involved in the writing of the 6th assessment report of the IPCC, which is coming out. Well, it's a wee bit delayed because of COVID-19, but it'll be coming out in about July, pardon me, I think July of next year. So about a year away. And we're about 3/4 of the way through the writing process. So I thought there's a lot in that report, of course, but just some of the things that have happened or been worked on in the last couple of years, I thought I might just cover tonight. And you know, I don't have lots and lots of slides or anything. Maybe we could just have a conversation about where things are at. So I shall call up. I've got a little PowerPoint here, and I'll see if I can share my screen successfully in this Zoom session. Let's see, where are we here? Share screen, yeah. Okay. And if I go to down there. Okay. All right. So can everybody see my presentation? Climate change, the latest from the AR6. So just to explain, well, first of all, the image in the background, which is pretty dramatic, that was featured in a news article on the 1st of January of this year, actually. And of course, it's a picture from the devastating fires in Australia over last summer, over the Christmas New Year period. And that featured in the New York Times and the Telegraph in the UK and so on. It went all around the world, I think. And it was absolutely amazing, the devastation from those fires last summer, following on from the northern winter in 2019, the big fires in California and so on. And certainly in this next IPCC report, the changes in the prevalence of fires, the intensity and the area covered is something that features in the report and the chapter on extreme events. So just to decode the latest from AR6. So AR6 is the next IPCC report, the 6th assessment report, that's what that stands for. And the working group 1 part of that, the physical science part of the report, that's what I'm involved in. And that's due to come out, yes, in July. I think the working group 2 and 3, that's the impacts and the mitigation parts, are due out over the subsequent 6 months or so. And the sort of final synthesis of everything will be out early in 2022. So really, I just wanted to cover a few things from the science that's been done in the last couple of years and preview, broadly speaking, some of the things that might be coming out next year. So let's see if I can make this work. There we go. So yeah, so what's new? I mean, a lot of the science is not new. We've understood what's going on for a very long time. But I think the way this climate has changed recently and some of the understanding of what's coming along in the next decade or the rest of the century has changed a bit just in the last year or two. So that's what I really wanted to cover. So what's happening with global temperatures, what's happening with carbon dioxide and, human emissions of various things, aerosols, that's air pollution basically. And also what's the consequences of the COVID-19 pandemic and the lockdowns that have happened in various countries. We know that we've seen all the news reports about the air clearing in a whole lot of countries, New Zealand included, and you know, waterways clearing up and fish appearing in places they haven't been seen for a long time, all that kind of thing. So, you know, what does that mean? Is it something that can be sustained? You know, what will it do for the climate, I suppose? I'll talk a bit about the latest crop of climate models, and there's been a bit of stuff in the media about climate sensitivity, that is, how quickly do we expect the climate to change in future? And there's been quite a lot of discussion about whether that's changed or not recently. The timing of getting to 1.5 degrees of warming. So there was the big report that came out from the IPCC nearly 2 years ago now, the special report on 1.5 degrees of warming, that was saying at the time, this is 2018, that to stop at 1.5 degrees of warming, we would need to reduce emissions globally by half by 2030 and get to zero by 2050. So this, the little headline from that report was 12 years to reduce emissions by half if we want to stop at 1.5 degrees, which pretty soon became 12 years to save the climate, and then 12 years before sort of the apocalypse or something. But that idea that if we can get on top of emissions starting in this year, 2020, and reduce them by 7 or 8% per year from here on, then we could stop at 1.5 degrees. So I'll talk about what the thinking is about that as of now, you know, a couple of years down the track. Sea level rise, which is a big consideration everywhere, but certainly in the Nelson region, and the continuing uncertainties around what the ice sheets are up to. Extreme events I'll mention very briefly, and just, you know, what's the latest thinking around future climate change? Have things changed in terms of our thinking around what the future will look like over the next 10 years, 50 years, and so on? So here's a graphic of the latest temperature records globally. This is from the NASA group in New York. It's one of many of these time series that you can see online. So this is what I'm showing here is annual average temperature differences from normal. I'm sure I showed a version of this graph when I was over in the Nelson region last year. I've just updated it. So each bar is a year, and the last bar is now 2020. And what I'm showing here is, I think if I just click, so if the rest of this year carries on in terms of differences from normal, differences from average, as warm as the first 5 months have done, then this is how 2020 would look compared to the rest of this record. So the zero line here is the temperature average before 1900, so the sort of pre-industrial, if you like. And we can see that the last 5 years, 2015 to 2019, have all been more than a degree above pre-industrial. But if 2020 continues as warm as it has done so far, you know, we'd be over 1.3 above pre-industrial. This year would be considerably warmer than any other year that's gone before. And look, I'm not saying that's going to happen, but what I am saying is if the year continues as warm as present, this is what we would see. The chances are that the differences from average will taper off a bit and things will die down. But there's a good chance that this year will be the warmest year on record. And that's quite remarkable, considering that 2016 is still presently the warmest year on record, and that's because there was a big El Nino event in that year, and that's a situation where the ocean in the tropical Pacific gives up a lot of heat to the atmosphere, so it warms the whole globe by somewhere between 1 and 2/10 of a degree. So there's nothing like that going on at the moment. In fact, if anything, slightly the opposite. The Pacific Ocean and the tropics in the Eastern Pacific are a little bit cooler than average. So there's definitely no sort of driving from the tropical Pacific happening, and yet this year is shaping up to be extremely warm. And a lot of the warming, if you've been following the news, it's been in the media a bit lately, it's been very, very warm in parts of the Arctic, Siberia, and across the whole of sort of northern Eurasia. They've been having extremely warm conditions over the last few months, and that's been pushing global temperatures up quite a bit. So this is more evidence, I guess, that global temperatures are warming very quickly, and the pace of climate change is definitely faster than it was even 10 years ago. I think if you look at the last 100 years, the trend in temperatures is a little bit more than 1 degree per century. If you look at the last 30 years or 40 years, the trend is over 2 degrees per century. So the rate of warming has definitely picked up in the last few decades. And like I've shown in every presentation I've given for the last several years, I think the reason is this, that carbon dioxide concentrations in the atmosphere have gone up dramatically, especially in the last few decades. So I think globally at present, we're up to about 408 parts per million or so, compared to a pre-industrial concentration of around 280 parts per million back a couple of 100 years ago. So, you know, it's human emissions of greenhouse gases that are driving the change in climate. And the latest IPCC report will certainly report on that and make it clear, actually, that perhaps the warming that's associated with this is slightly larger than was estimated before. And part of the reason for that is that I think we underestimated in the past how much cooling came from aerosols, from air pollution, essentially. So it's really the difference between the cooling from industrial activity, air pollution, and the warming from greenhouse gases that gives us the change in temperature that we see. So, 10 years ago, I think the thinking was that the air pollution wasn't having all that much of an effect, but we've come to realise that it's actually a wee bit stronger than we thought before. So the sort of warming in behind that from greenhouse gases is actually a bit stronger than we thought before. So if the air was to clear, such as we've seen recently with the shutdowns with the pandemic, then you might expect to see, in the short term at least, a bit of extra warming as you get more sunlight coming through to the Earth's surface, basically. So we're still in the situation, you know, the first half of that rise in carbon dioxide since the start of the Industrial Revolution took over 200 years to occur, and the second half has taken only 30 years or so to occur. And that rate of rise of emissions, which has been exponential in the last century, is still going on. We've seen a drop this year with the shutdowns of something like 7 or 8%, which should come through to, the annual average might be something like that, or maybe 5 or 6, somewhere between 5 and 8% decrease. And that's the kind of number we'd need every year, actually more than that, every year from now on, to really cap the increase in carbon dioxide at levels that would stop the warming at, you know, certainly, well, less than 2 degrees. I'm not sure about 1.5 degrees. And the latest report will make it very clear, as we've known for a while now, that this level of CO2 in the atmosphere is something that we haven't seen for millions of years. And the last time the climate system had this much carbon dioxide in the atmosphere, temperatures were a bit higher than they are now, and sea levels were several meters higher than they are now. I'll talk about that a little bit in a bit, but that's I think still to be decided. So this business about aerosols, about air pollution, just to say a few words about that. It's maybe not so relevant for New Zealand, although, you know, locally, I know that Nelson has issues with in the winter at this time of year with smog in the city and so on. The topography is such that you get these stable layers of cold air in the winter, and you get quite bad pollution, or there can be quite bad pollution in the city at times. But anyway, on a sort of more regional or global scale, industrial activity, especially in the northern hemisphere, especially in parts of North America and more recently in Asia, has put a lot of smog, a lot of sulfates, a lot of soot and so on into the atmosphere, and that has acted to cool the climate more than we thought a few years ago, I think. And one of the big influences has been that the monsoons, especially the Asian monsoon, which affects India and South Asia and up through to China, has been quite influenced by the amount of rubbish that we're putting into the air in that part of the world. So the expectation as the climate warms is that the monsoons will get more intense, more moisture in the air because the air is warmer, but the cooling effect and the effect of these aerosol particles on clouds and how they operate has overridden that basically, and it's actually acted to reduce the intensity of the monsoons in the last 40 or 50 years. And we're starting to get a clearer picture of how that works. So we're starting to get a bit more confidence about what will happen in the future, assuming that we do reduce pollution in the long term. And that leads on to this question about COVID-19 and what's happened this year. And certainly there's an example, China and India are great examples of that, where air pollution levels dropped dramatically and suddenly you could see the mountains and all the rest of it. And I suppose one question from a scientific point of view is that, has that actually affected the climate? You know, that should have led to a bit more warming because suddenly the sunlight could get through to the ground level. And maybe this year's monsoon in India and so on might be a bit more dramatic. Or maybe that's just too short-term a thing to really have an effect. But either way, the IPCC report itself has been delayed a few months. So there's now the decision's been made to wait until the end of January of 2021 to collate all the data from 2020 so that we can make some kind of at least preliminary study of, you know, what was the effect of all of this. Can we say whether there was a discernible effect on the climate globally? And if so, what would that tell us about the future if we do manage to decarbonise the economy and reduce both greenhouse gas emissions but also air pollution levels? And happy to talk about that when I've finished, but yeah, I'll say no more about that now. Just moving on, sea level rise, which is always a big topic. I don't actually have an awful lot to say here. Pardon me, just having a cup of tea. Here's a graph of sea level change over the last 30 odd years. This is from the satellite record, and the trend is presently about 3.5 millimetres per year. This is the global average increase. There has been an acceleration in sea level rise in the last century, and this is very well documented, or will be in the next IPCC report. And the big uncertainty here is really around what the big ice sheets are going to do. How much will they contribute in future? And it's still quite uncertain. I think that the expression that's used, that will be used in the report, is that there is deep uncertainty around just when and if the big ice sheets will kick off and parts of them start melting irreversibly. We're getting quite close to these thresholds, but I don't think we're quite there yet. So if we look at the record from Greenland and Antarctica from the satellite era going back to 2002, we see this quite dramatic decrease in mass. So what we've got here is time along the bottom and loss of mass of ice in gigatons, billions of tons. So each of those tick marks is 1,000 gigatons, a trillion tons of ice. So Greenland's melting pretty fast, Antarctica's starting to catch up. And between the two of them, in the last 17 years or so, they've contributed about 17 or 18 millimetres to sea level, which is not a lot, but there's an awful lot of ice in both of these ice sheets. And the latest thinking is that if we get to above 2 degrees of warming, it's pretty likely that parts of the Greenland ice sheet will melt irreversibly. And the West Antarctic ice sheet, it's still pretty uncertain basically, but the chances are that we would see the same kind of thing starting off in the West Antarctic at around 2 degrees of warming, maybe a little bit more. And that would lock in somewhere between 5 and 10 metres of sea level rise in total. It would take hundreds of years to happen, but we would not be able to stop it once it started. So that's still a big uncertainty, and it will still be a big uncertainty when this report's published next year. But it is a major consideration, I think, for policymakers, that we need to be thinking about the possibility of meters of sea level rise over the coming few centuries. For this century, the numbers still look about the same, up to something like a metre is on the cards this century, somewhere between half a metre and a metre, which are the sort of numbers that have been used and taken up by policymakers over the last several years or so. So I just wanted to get on, there's been something else that's been in the media lately about climate sensitivity. And I'm not going to go into all the details here, and I'm guessing some of the audience probably know at least as much as I do about this topic. So one of the pieces of evidence that's used in these reports, or just in the science generally, is what climate models say about this thing, the climate sensitivity. So I've got a little diagram schematic here of the CMIP-6 set of experiments. So CMIP stands for Coupled Model Intercomparison Project. So this is a big international effort to compare all of the different climate models that different research institutes and governments use around the world. And this is the 6th round of intercomparisons to go along with the 6th report of the IPCC. And the 6th generation of these models, which have been run over the last year or two, turns out that, well, they're always getting better in the sense that they have higher spatial resolution, better representation of the topography of different countries and so on, better representations of the physics of the way the atmosphere operates, things like clouds and radiation and so on. And the latest generation of these models have started to show up higher sensitivity than previous generations. So what this climate sensitivity thing is it's a convenient number to use to understand how quickly the climate changes, really. So if you double the amount of carbon dioxide in the air, how much does the global average temperature go up? That's what the climate sensitivity is. And in the past, or actually for 40 odd years or so, there's been a understanding that that number, the sensitivity, is around 3 degrees plus or minus. So you double carbon dioxide, you get about a 3 degree warming globally. But some of the new models are challenging that view, and it's a worrying turn of events. So it's a very interesting question scientifically, though. So this climate sensitivity has been estimated to be around 3 degrees for many, many decades now, with a error bar, somewhere between 1.5 and 4.5. So 3 degrees plus or minus about 1.5 degrees. And this is based on model experiments. It's based on understanding the ups and downs of the ice ages and how much carbon dioxide changed through hundreds of thousands of years. It's based on our observations of the climate over the last century and how much greenhouse gases have changed in that time, and so on. So there's many ways to approach this question, but these climate models, the latest generation, have departed a little bit. So some, not all, but some of the new models are showing numbers that are more like 5 or 6 degrees sensitivity. So saying that if you double carbon dioxide, you get 5 degrees of warming, or maybe even up to 6 degrees of warming, rather than 3 or 4. And this is in models that I would say have a better understanding or treatment of how clouds operate, a higher spatial resolution and all the rest of it. And these are not consistent with our previous understanding. Doesn't mean they're right. It doesn't actually mean they're wrong either. So it's a big topic of research at the moment to understand why this is happening. There's some support for this because some of the new research looking at observations of clouds have shown that it's pretty likely that as the climate warms, a lot of the low clouds in the tropics might start to evaporate, and they reflect a lot of the sunlight that would reach the Earth's surface otherwise. So if that happened, then yes, you would expect to be seeing more warming more quickly. So it's plausible that this could be true, but it seems a wee bit outside the expectations based on the ups and downs of the ice age cycles and so on. So it's something to look out for, I guess. But the next report coming out next year, I think, will summarise all this by saying that actually it's likely that things are going to warm up a bit faster than we thought in the past, which is a bit of a concern. So yeah, if this is true, if it pans out in terms of other ways of looking at the problem, that would mean that the climate is warming faster than we thought before and will warm faster in the future. So this idea that 1.5 degrees of warming, if we can get to halving emissions in 2030 and zero by 2050, those timeframes might be a wee bit optimistic, perhaps. So it really reinforces the idea that we need to just get to zero emissions ASAP, basically. So look, you won't be able to read this hardly, but I'll email the PowerPoint. There's a couple of nice pieces that have been published recently about this. So a colleague of mine in Australia published a piece on the Conversation website a few weeks ago, just how hot will it get this century? And in response to that, I wrote a little piece for an outfit in Auckland called The Big Question, thebigq.org, on the same topic and what it might mean for New Zealand. So have a look at those if you want to read a bit more, and if you want to get into it, there's all sorts of scientific literature out there to read. So what about the future? So this is a bit of a change actually that we'll see in the new report next year, I think. So here's our graph of carbon dioxide. It's going up. We need to stop that happening. We're at about 1.1 degrees of warming. If you average over the last 5 years or so, or maybe even 10 years, you get about that level of warming. And the question is, well, how quickly do we get to 1.5 degrees, 2 degrees, 3 degrees, and so on? And I think when I was talking about this last year, I was saying if we do nothing, we would get to 1.5 degrees of warming in 10 years, i.e. by 2030. And the IPCC and the models and so on, they use various scenarios for the future. How much are we going to emit? How quickly will we reduce emissions and so on? And there are pathways for the future that would see us stopping at 1.5 degrees. The latest report, I think, looking at all of the new scenario, all of the current scenarios and all of the current models, the modelling fraternity have worked out that basically this statement here, 1.5 degrees of warming in 10 years, is virtually guaranteed now, unless there's some kind of catastrophic reduction in emissions over the next few years. Whatever we do, we're pretty likely to get to 1.5 degrees of warming by about 2030. That is almost locked in at this point. And following on from that, if we continue to take no action, another 10 years, it'll be 2 degrees of warming. Another, I don't know, probably a bit longer, 20, 30 years after that, 3 degrees of warming and so on. And the Zero Carbon Act, which New Zealand has now, and the goals of the Paris Agreement and so on, talk about getting to zero carbon dioxide by 2050 and getting to half of our emissions being reduced by 2030. And that would also give us 1.5 degrees of warming. And that, I guess the summary that will come out next year is that it's becoming so hard that it's very unlikely that the globe will actually achieve these reductions in emissions. So this 1.5 degrees of warming is virtually guaranteed now. But it's still the case that if we could reduce global emissions by half in the next 10 years, that's like 7 or 8% reductions per year from now on, then we could still bring it in. But I think 1.5 degrees of warming is almost definitely on the cards. I'd like to think we can stop at less than 2 degrees of warming. We've still got a bit more time. Can buy a bit more time there. But, you know, it again reinforces this point that, you know, we really need to be doing things as fast as we possibly can to cap the warming at as low a level as we possibly can. Okay, so just a couple of things about the sort of local scene, and these are numbers that I showed last year that I've been talking about for quite a long time. You know, 2 degree warming means a tripling of the number of hot days, and it gets drier in the dry places like Canterbury, Northland, Hawke's Bay, and you see a tripling of the occurrence of droughts, and put those together and you get something like a doubling or a tripling of the length of time in the year that those regions are either in very high or extreme fire danger. And those sort of numbers haven't really changed, but I guess the timescale has changed a bit. How quickly are we going to get to these kind of numbers? And again, if we don't see significant action internationally on reducing emissions, then we could be at these sorts of changes in New Zealand well before the end of the century, you know, maybe by the 2060s or 2070s. So it's really, I guess it really reinforces the idea that these are the kind of events that really hurt populations and hurt ecosystems. And those sorts of extremes start occurring quite early on as you change the climate. So we're going to see events like the Australian bushfires and the Californian fires. Similarly, the big heat waves in Europe, had a big heat waves there last northern summer, and the drought that's been occurring and actually still going on in parts of New Zealand lately are going to become more and more commonplace as time goes on. And yep, sea level rise and coastal erosion definitely on the cards. And like I was saying, the numbers here haven't changed too much. Still expecting something like 30 centimetres further sea level rise in the next 40 years or so, which is more than we've had in the last 100 years. And the range for the rest of the century and beyond is still very uncertain, definitely at least half a metre. But the upper limit is, yeah, sort of your guess as good as mine in a way. It really depends on how much warming occurs. So if we can stop the warming at less than 2 degrees, then we should stay on the lower side of those big limits for 2100, hopefully less than a metre, but it really does depend on reducing emissions. Oh yeah, I won't worry about that one. So this, just to make this point again, and this is from the Parliamentary Commissioner's report from a few years ago now, and this was looking at Wellington, which was reasonably close to Nelson, but quite different bathymetrically and so on, but it tells a story. If you have a coastal erosion, coastal inundation event that occurs once in every 100 years with no sea level rise, so what's the current situation? Then for various levels of sea level rise, you see how quickly the frequency of those events changes, and it's really quite dramatic. So by the time you've had 50 centimetres of sea level rise, which is essentially guaranteed this century, then you've gone from a 1 in 100 year event to being once every couple of weeks. So this is, again, just because the coastlines, the beaches are pretty flat. As the sea level rises, the high tide mark comes inland quite dramatically. So you get up to a metre of sea level rise, and pretty much the extreme event from last century is now the average, or maybe even below the average. So the coastlines are definitely coming inland, and retreating from the coast is going to be one of the big issues to deal with over the coming decades. Oh yeah, that's a graphic of where we might see the Antarctic ice sheets sort of kick off with melting. So this is a contribution to global sea level from the Antarctic ice sheets through time along the bottom there, with different scenarios for the future. So the black line is where we do the 1.5 degrees or less than 2 degrees of warming, and really we get very little melting from Antarctica. The vertical scale is sea level change in metres just from Antarctica. And if you even get above 2 degrees of warming, the blue line, you start melting the West Antarctic and you end up with 5 metres of sea level rise in a few hundred years. And if you really push it hard and you get 3 or 4 degrees of warming this century and beyond, then you start to melt the East Antarctic ice sheets and Greenland as well. And you end up with 10 or 15 or 20 metres of sea level rise over the next few centuries, which of course would be, well, most of those scenarios would be absolutely catastrophic actually for many countries. Okay, so just to summarise where I think we're at compared to even a year ago, I think it's safe to say that the observations and the model results are saying that the climate's changing faster than was really anticipated or measured to be even just a few years ago. And so the time for action is even shorter than we thought. We're talking about halving global emissions in 12 years in 2018. I'd say we're now talking about halving global emissions in 7 or 8 years from here, which is looking very, very difficult. But, you know, the message is still that this is our problem. We are causing the climate change, and we're the ones who can stop it. So, yeah, it looks pretty dire, but it's totally down to human activity. If we can stop or reduce greenhouse gas emissions starting now, then, you know, as soon as we stop carbon dioxide increase, we'll stop the warming. And there's an interesting discussion in this new report about, well, how much more warming would you get? How much is sort of baked in? If you stop the emissions today, how much more warming would you see in the climate? And it's actually quite uncertain. My estimate has been, it'd be 1 or 2 tenths of a degree. And that's about the average. But some estimates put it at half a degree more. Some estimate that there would actually be cooling over the following decade or so by a little bit, you know, a tenth of a degree or so, for various reasons, take up of heat by the oceans and so on. So it is uncertain, but the chances are there would be a bit more warming once we do stop emitting greenhouse gases, especially carbon dioxide. But that warming, it would not be large and it would play out fairly quickly. So it's still the same message, that if we can stop emitting greenhouse gases, we can stop climate change. We really do need to get on with it, and that's becoming more and more apparent as time goes on. But it's still possible, and I think we just need to push as hard as we can. And I think that was it, yeah. So I'll stop sharing, and very happy to take questions, have a chat, get your feedback. I think I've sort of gone on for a bit longer than I thought I was going to, Julie, but there we go.
Oh, I could listen to you talk all evening, James. Thank you so much for that. That's really interesting to hear what's much the same and what appears to be changing, particularly the timeline that you've been expressing this evening. Really interesting, and I feel quite very lucky to have a little insight into what's coming up in that next report. I guess as I was listening, I was thinking about hope, and you touched on it at the end there, that we're still in control, there's still chance. I was listening to an interview with Jonathan Porritt earlier today, and he's written a book, Hope in Hell, and he talked about how his hope comes from youth activism and on the world's massive expenditure for the COVID-19 recovery.
Yeah.
That's where his hope comes from. And I just wonder, where do you find your hope as someone who's immersed in what Jonathan Porritt calls a somewhat gloomy outlook?
Great question, Julie. Well, I think I find hope in some of the same places and same areas. I think the school strike movement has been really transformational, and I come across a number of young people, both, school kids, activists, people working in government agencies and so on, but also students at university who are just well, very knowledgeable about the problem and really committed to making a difference. And there's a number of young people who voted on to various local authorities in the last local body elections last year, who I think are really starting to shake things up. And I know that time is short, but I do see a lot of action, a lot of activism from young people, and I think that is really going to change the world in due course.
Kia ora, it's one of my hopes as well. So in your recent media pieces, you've reminded us that per head of population, New Zealand is number 6 in the industrialised world in terms of greenhouse gas emissions, meaning perhaps we have as much obligation as China or the US to reduce our emissions, and that intensive agriculture and the transport sector are our major pain points, if you like, nationally. We've heard that Stats New Zealand is producing an emissions profile for each region. We haven't had an update on this, but regardless, Nelson Tasman has kind of a unique profile. We've got relatively low numbers of sheep and cows relative to other regions. If we consider Nelson and Richmond one urban area, there are 11 towns and cities in New Zealand larger than ours, so our share of the transport-related emissions will be modest. We've got large areas of natural and plantation forests, and before COVID-19, a population was tipped to grow between 11,000 and 25,000 residents, which is a quarter again, thousands of new homes. So given the lack of an emissions profile for the region to guide us and the uncertain times that we're living in, what are your thoughts about how our region could best lower emissions, contribute to lowering national emissions, and to setting an example for both our country and others? Question from our science and research team.
Right, what a great question. Wow. I'm not sure I've got all the answers here, but and I haven't seen these new regional statistics that are coming out on emissions and so on, but I think it'll be very interesting to see. And I think, yeah, the Nelson region may be, I don't know if it would be a net sink of carbon, but it's certain that there is a lot of forestry, horticulture, agriculture, viticulture in the region, and yeah, the population density is relatively low over most of the region, and yeah, transport emissions are not large. So I would say that Nelson and the Tasman region starting off from a fairly low base, but I guess with these projections for population increase, I think it'll be important to keep on top of that and make sure, or at least try to avoid, urban sprawl, and look at having sort of smart urban developments, high density housing, minimise the amount of increase in transport emissions from light vehicles, from people driving their cars, basically. So whether that's electric vehicle infrastructure or pumping up the public transport system, or just having people living close to where they work so they don't need to drive and so on, that's all part of that mix, I suppose. So trying to maintain where things are at now would be a very good thing to do. And whether or not the region can look at developing things like regenerative agriculture, biodynamic farming. I know there are some wineries that are zero carbon, and that might be through a combination of offsetting and reducing emissions in their production facilities and so on. So I'm not sure of all the sort of answers there, but I think the region could be the last part of the question about being an example to the rest of New Zealand. I think that's a really important thing. The Nelson region, the Tasman district, could be, the preeminent place in New Zealand for a low carbon economy. And what that might look like, I'm not sure, whether that's, educational facilities or solar technology. It's one of the sunniest places in New Zealand, so you would think that solar farms would do really well somewhere in the region. And I'm just speaking off the top of my head here, but I do think I like that idea of sort of being a leader, being an example. I think different parts of the country, it'd be great if we all had a bit of friendly competition across New Zealand to be the lowest carbon part of the country, and then New Zealand could be an example to the rest of the world in terms of low carbon technology, and we could export what we learn from doing this kind of thing to other countries. And I think, New Zealand, Nelson, if we reduced our emissions to zero, big deal. It wouldn't make much difference to the global climate. So we have to help other countries do the same thing. And I think this coalition of small emitting states is really important, and how New Zealand can negotiate and share knowledge with other countries about how we achieve these reductions in emissions, assuming that we do. It's the law now, but we haven't actually seen much action yet. But that's the plan over the next few years. So I think, as much creativity as possible is really what's required, as much sharing of knowledge, as much cooperation, and just thinking about every, this idea of the green stimulus after COVID-19, every piece of infrastructure that's built or every bit of investment that's made, is it being made in a way that will reduce emissions, or is it locking in high emitting infrastructure for the future? We really need to avoid locking in infrastructure that is going to cause emissions into the future. This is this idea that really, the next year or 18 months is a crunch time, because if we make the wrong kind of investments now, that's going to commit us to a lot more emissions of greenhouse gases for decades probably, and that's really something to be avoided.
Kia ora. And I suspect you'd encourage everyone to get involved with the upcoming elections with that time frame in mind as well.
Indeed, it is an election year. Yeah, there will be an election in only a few months now. So I'm not about to tell people how to vote at all. But I think if you're concerned about the climate, and everybody should be, in my opinion, then do think about how different parties would respond to climate change, and at meetings of candidates, ask the candidates what is your stance on emissions reductions, on climate change, and I think vote accordingly, basically. Yeah.
Thanks. Now, you mentioned infrastructure just before, and one of our local councillors, Rachel Sanson, has a question for you relating to infrastructure, and particularly to resilient infrastructure. I'll just hand over to her.
Okay.
Thanks very much, Julie. Good evening, James. Lovely to see you again, and thanks for the great presentation.
Oh, yeah. Hi, Rachel.
Hi, how are you doing?
Good.
So, James, I guess, as you're aware, I'm on council, and we are, making decisions all the time about infrastructure investment. You referenced needing to plan for retreating from the coast, and I'm curious, at a local government level for Nelson Tasman specifically, is that something you think that we should be planning for now when thinking about infrastructure investment and renewal?
Yeah, definitely. And this word infrastructure can mean many things, I suppose. Most of us think about roads and buildings and, bricks and mortar in some sense. And if that's what we're talking about, then yes, it's very important to think now, because, we build things, public infrastructure, roads and power lines and stormwater drains or private homes, and they're going to be there for decades, for the rest of the century at least. So if we go down the wrong path, go down the path that we've been going down for the last 50 to 100 years, now, we are going to lock in high emitting infrastructure for quite a long time. So definitely now is the time to be thinking about this, and now is the time to be making those kinds of decisions around where do we invest.
Yeah, I think I'm particularly interested in where we are investing in areas that might be at risk of inundation.
Oh, right. Yes,
and,
yes.
and should, thinking of an asset with a life of say 30 to 50 years, for example, a library on the riverside, is that something that is, prudent to be, or is it imprudent actually to be kind of considering those kinds of investment decisions at this time? Or is it far enough off that we can just go, oh, well, there'll be some solution to inundation and we'll be able to hold the sea back?
Well, I mean, that is a possibility, that we can hold the sea back. We can build sea walls, we can pump water and so on. And I was speaking to somebody from the Netherlands a couple of weeks ago, and the Dutch are the gurus at this. They've been living below sea level for hundreds of years. So it's possible, but it would come at a huge expense, and it would involve things like, massive sea walls and pumping stations and all the rest of it. It would require a lot of pretty serious building works and infrastructure. And I think, I'm not sure about the exact site that you're mentioning here, but the coastline, the coast is coming inland. That's what's happening. And you can build a seawall, you can do whatever. Eventually that will fail at some point in the future. And really the reality is we need to move with the coastline and come inland. So if there's discussion of building new public infrastructure close to sea level near the coast now, then I think that really needs to be thought about pretty seriously. And I guess the riverside, river flooding's another thing, that if you're not by the coast, you're probably near a river that's likely to flood more in future. So that's another issue. And yeah, the frequency of big floods in rivers is expected to go up by another, factor of 2 or 3 this century around most of the country. So getting away from riverbanks, getting away from the shoreline is really an imperative, I would say. If we're going to sink money into building new public buildings, we want them to be in places that will be around and be okay for at least 50 or 60 years. And, we're expecting on the order of 0.5 metre of sea level rise in that time. And that's going to change the landscape around the coast dramatically. The frequency of these coastal inundation events will go up hugely with that sort of rise in sea level.
Kia ora, James. Thank you for that. And thanks, Rachel, for that really clear question. You touched briefly on energy. You were talking about solar energy here and so on. A question came to me in an email earlier on, touching on 100% renewable electricity and whether that's the best place to put our resources, or perhaps whether focusing on renewable total energy, heating and industry and so on, would be a more useful place to put our energy. And another question for energy has just come into the chat about the impact of energy descent, global energy descent, and the change of energy availability worldwide, and whether that is something that the Climate Change Commission is considering when it's thinking about renewable energy transition.
Right. Okay. Well, the first point about 100% renewable electricity, and then looking at renewable energy generally. I totally agree that we need to get to a point where all energy production comes from some renewable source, and that, in a lot of ways, that implies electrification of the use of energy generally, whether that's in industry or for transport or home heating or whatever. So I guess getting to 100% renewable electricity with our present system is the easiest thing to do in the short term. We're already at 80% with all of the hydro and so on. So if we could get to 100% renewable electricity, that would be good. But then we need to electrify pretty much everything else anyway. So we would need to go to a electrified transport network, whether that's public transport or private vehicles, freight vehicles, whatever. And so that would imply, more than 100% use of our present electricity system. So we need to get to way more than 100% of today's electricity generation. And beyond that, we need to be looking at generating enough energy from renewable sources to do basically everything we want to do, power and industry, maybe even, do things like make steel and so on, if that's possible renewably. Well, I know in some places. So all of our industrial processes, all of our transport networks, ultimately will have to be powered renewably if we are going to get to zero emissions. And that point about, I think, energy descent, did you say, Julia? So this is what the site, is this talking about energy efficiency? Is that?
It's talking about how much more energy it's taking to get the same amount of energy available for society. And as that trend continues, the possibility of reaching a point where we don't have enough available energy to continue with business as usual.
Right.
And particularly as renewables tend to have less energy available for energy input. Yeah.
Right. It makes me think, the reason we burn fossil fuels is they're incredibly good. The energy density of a litre of petrol or a lump of coal is pretty impressive. And so you get a lot of bang for your buck when you burn it, and it's hard, it's impossible really to reproduce that kind of energy efficiency, energy density out of a solar panel or a wind turbine. But, and look, this is way outside my area, and I talk to engineers who are, skeptical is the wrong word, but maybe realistic about what's possible here. To build wind turbines, to build solar panels, to build all of this renewable infrastructure, you need rare earth minerals, you need copper wires, you need a whole lot of stuff dug out of the ground. Not oil and coal necessarily, but a whole lot of other things. And whether there's enough natural resources in that sense to actually make all of the solar panels and so on to power the world, I'm actually not sure. I think we need to try to move in that direction. And I'm aware of research going on around different kinds of compounds that could be used for things like solar panels, so we might not have to rely on some of the rare earths and the silicon and so on that we're using at the moment, and maybe other compounds that are other elements that are more common could be used. So it's a very much a watch this space situation. But I just don't know the answer to that question. It's possible that we may not be able to produce as much energy renewably as the world uses at present, or if all of the population of the world was at the kind of standard of living of New Zealand, it may well be impossible. Full stop. I'm not sure about that, but there are some really big questions there around international equity and inequality in terms of living standards, energy use, modes of transport, and technology and so on and so forth. Income, basically, GDP. And that's a much wider discussion, but it is part of the story with climate change. If we're going to solve this big environmental problem, it really does come down to solving a whole lot of other social problems that, relate to how we got to be in the situation we are today, with a bunch of very well-off countries and a whole lot of not so well-off countries. And how do those countries get to be like New Zealand or Australia or the US? And that's a pretty hard question.
It's a hugely complex issue, absolutely. Maybe one more question before we sign off, would that be okay?
Yeah, sure.
Fantastic, thank you so much for this time. It's one that's really been intriguing me for a while. It's about the role of water vapour in the air. And in particular, how much the loss of moisture from the soil and from vegetation through deforestation might have contributed to climate change. And if there is a significant contribution, what the potential is for reforestation and revegetation to help mitigate climate change acceleration?
Wow, that's a really great question. And there's a lot of parts to that, I'm thinking. So first of all, yeah, water vapor is a very important greenhouse gas, and it's more efficient than carbon dioxide at absorbing infrared energy. So it amplifies the warming that you get from increasing CO2 and so on by roughly a factor of 2. So if there was no water vapor in the air, the amount of warming we'd get wouldn't be that dramatic at all. The thing about water vapor is there's this unfortunate relationship that the amount of water vapor in the air is purely related to temperature. You warm up the air and you get more water vapor, and it's an exponential relationship. So that the water vapor goes up very rapidly as you warm things. So you get a big increase in the warming from extra water vapor. So that's the underlying issue there. But yeah, drying of soils and deforestation and so on. Yeah, this is definitely a feature of the way we're seeing the climate changing already, and the way it's expected to change in the future. That over land surfaces with warmer air and more intermittent rainfall, which is what's expected, should we get bigger dumps less frequently, rather than a more sort of equable distribution of rainfall. That when it's not raining, the soils are going to dry out faster because it's warmer. And so you get into situations of large soil moisture deficits more quickly. And yeah, so that would, the drying of the soils would add water vapor to the atmosphere, certainly. And yeah, deforestation's a somewhat different issue, I would say. I mean, there's a lot going on there with the way land is used. If you've got grassland rather than forest, then the reflectivity of the Earth's surface goes up. So that actually cools the Earth a little bit by itself. But then the trees are absorbing more carbon than the grassland would be. So that's a warming effect. And so on. There's various influences there. So it's a little bit hard to say, but the water vapor part of the story, I would say, is not that big a deal in a sense. The reality is 3/4 or 2/3, no, 70% of the Earth's surface is covered in ocean. And that's where most of the evaporation happens. And that's where most of the water vapor comes from. So the land surface is likely to become, to dry out more quickly, to become more variable. It can be wettened quickly by these big rainfall dumps, and it can dry out fast when it's sunny. But the net input of water vapor into the atmosphere may not change all that much. But over the oceans, as the climate warms, the amount of evaporation increases, and that's mostly where this increase in water vapor in the air comes from. So it's changes in evaporation of the oceans that really counts the most. In terms of land use, deforestation has all sorts of ecological effects, but I think the overall effect on the climate, it's one of those things that's quite hard to say. It depends whereabouts in the world you are. In some places, the reflection of sunlight part of the story outweighs the absorption of carbon dioxide, but in other parts of the world, it's the other way around. So it's a bit of it's a mixed bag in terms of direct effects on the warming of the climate. But it's a big deal for regional ecosystems and regional cycling of gases, the carbon cycle and the nitrogen cycle and so on. And one of the big worries is about the Amazon rainforest, for instance. If the climate continues to change much more, will most of the Amazon rainforest die off, and will that whole area of South America dry out and so on? And yeah, there are indications that could happen. There could be significant die-off of the Amazon over the next 50 years or so if we see another degree of warming or so on. And that would be, well, in a lot of ways it would be a terrible situation. It would change the regional climate in South America quite dramatically, but the effect on the global climate may not be all that significant. but it would be, you know, it would be a huge deal for South America, and similar things happening in other regions of the world would be very big news regionally. But sort of wandered around on this a bit, but I think in terms of water vapour, it's really what happens over the oceans that matters the most.
Kia ora, thank you so much for that. I really appreciate that. We've had a couple of other questions come into the chat, but I think it's probably just about time to close us off, getting past 9 o'clock. So what I might do is email those to you if you're willing, and respond that way. So just to finish off then, how can people keep in touch with the work of the IPCC, the CCC, and you generally?
Right. Well, the IPCC process, I guess there's a round of revision happening now, and you know the full report will be out next year. The IPCC itself puts out statements on some of the recent science from time to time, and you can just go to their website to see what's happening. So that's just ipcc.ch, which is the internet abbreviation for Switzerland. Have a look there. The Climate Change Commission has a website. And I was going to say not exactly what the address is, but I'm just going to look it up to make sure I get this right. Yeah, it's Climate Commission. So forget about change. Climate Commission, that's all one word, .govt.nz. And that's, they're just in the process of updating the website. It's a wee bit, well, it's going to be fancier in a few weeks apparently, but it's not bad now. And so if you want to go on there, you can see what's happening. You know, the Commission is working on its first budget for New Zealand for emissions reductions over the next 5 years, and that's going to be tabled early next year. But the Commission has made a number of submissions to government and written to ministers and various people about the COVID recovery and so on, and all of those letters and things and submissions have been made are on the website, so you can go on there and have a look. And under the news, I think it'll have a list of all these different things that have been happening and what the Commission has had to say about various things, the emissions trading scheme and so on. So that's a good place to look too. And the Ministry of the Environment is doing a lot of work on under the environmental reporting legislation. They're preparing a new report on the state of the New Zealand climate and the atmosphere, which has got quite a lot of stuff on the changing climate. I've been helping edit that latest report just in the last few weeks. That's coming out sometime in the next couple of months, I think. So mfe.govt.nz, they have quite a lot of stuff. They've got reports on the oceans around the coast about fresh water, the one that just came out recently, so rivers and lakes basically, and the atmosphere and climate one's going to be coming out in the next couple of months or so. So that's another good place to have a look. And if all else fails, you can always send me an email and I shall try to answer a question or point you in the right direction.
Awesome, thank you. And if people want to keep in touch with the Climate Forum, then you're very welcome to go to Nelson Tasman climateforum.org and sign up on our forum on there to get involved with all the work that's happening across the community. Certainly there's a lot going on and we need as many people as possible to help make this hugely complex response happen in this region. James, thank you again so much for being here. It's been a fascinating discussion. And
well, my pleasure.
I really appreciate it. Kia ora. Te Wehi, I wonder if I can hand over to you to close us off for the evening. Thank you for joining us. Appreciate it.
Oh, you're very welcome. Kia ora.
Kia ora, James. Ngā nui ki a koe. Thank you for coming on tonight and giving us your time and sharing your knowledge with us all. It's really promising to see. I think when I came on, 60 odd people listening to you and taking everything in that you're saying. So it's just really cool. Thank you for everyone for coming on tonight as well. You know, this is all building up to the point that where we start seeing that change. So Kia ora. Anyway, karakia, and we'll let you fathers go. Kua mutu o mātou mahi mō tēnei wā, manaki tia mai mātou katoa, o mātou whānau, aio ki te aorangi. Our work is finished for the moment. Bless us all, our colleagues, our families. Peace to the universe. Kia ora.
Kia ora. Thank you all.
Yeah.